IGCSE coasts. So, what is a coast? Well, the coast, or known as a coastline, is the border between the land and the sea. The coasts are very important because they have many uses for humans, but, at the same time they're also a threat because of humans. So why are coasts important and how are they used? Firstly, tourism. There are many resorts along coasts and tourists do enjoy using the coast for things like swimming and sunbathing. Also, sport. Many sports use the coast, for instance, sailing, surfing, diving, kite surfing, and stuff like that. Ecosystems. There are many unique ecosystems along the coast, like mangroves, sand dunes, and estuaries. Also, the biodiversity along the coast is varied and unique. Fishing. Oceans are full of fish, although supplies are declining, but many people make their living from catching and selling fish. Aquaculture, which is seafood farming, also takes place along the coast. Oil and gas reserves. Much of the world's oil and gas is found under the oceans. Ownership of these reserves is very important. Housing. Many people choose to live along the coast, like you will find that in Malibu, because of its beauty and the relaxing lifestyle. Or anywhere in Cali, really. Industry. Many industries like to locate near the coast because it's easy to trade since it's a break of bulk location. Transport. The oceans are used to transport people and goods. So, many ports are found in coastal areas and help allow trade between countries as well as movement of people with boats and stuff. Walkers. Many people enjoy walking, cycling, or riding along coastal paths and coastal areas. Why are coasts under threat? Well, the sea level rises because of global warming, right? So low-lying countries like Bangladesh will be very vulnerable. So the reason that coasts are first under threat is because global warming warms up the place, so the ice caps melt, so there's more water in the sea, so the sea level will obviously rise. So there are countries like Bangladesh, they're not very high up, so they're right on the sea. They're the same kind of height, right? So even if the sea level just rises by like 10 centimeters, it will flood like the whole place. So that's a problem. So that's why that coast would be under threat. Low-lying coasts. Well, coasts in low-lying countries will be under threat because of the sea level rises caused by global warming. Pollution from sewage discharge. That's a threat for coasts. But also accidents like the recent BP, British Petroleum oil spill in the Gulf of Mexico. Litter. Litter thrown into the sea can kill animals. Turtles often mistake plastic bags for jellyfish and then eat them and die. Overfishing. Many fish stocks around the world are being overfished to dangerous levels. Erosion. Many coastlines are being eroded by stronger storms and also by rising sea levels. Tropical storms. Because of rising sea levels, the frequency of storms and magnitude, so the strength, are increasing, causing flooding, storm surges, and wind damage. Privatization. More and more stretches of the beach are privately owned nowadays by houses or hotels, etc. This is making it increasingly hard for locals to access previously open areas. The privatization of areas is also increasing the cost of land, making it less affordable for many residents. So, waves. Waves are formed because of friction between the wind and the sea. Although it appears that water particles in waves are moving forward, in reality it is only the shape and the energy of the wave that is moving. Water particles tend to move up and down in a circular motion. When waves near the coast, when they are near the coast, near being the wave, the verb, what am I saying? Sorry, it's kind of late. The bottom of the wave is slowed by friction with the seabed. Because the top of the wave is experiencing less friction, it moves faster, and eventually topples over the bottom of the wave and breaks. The size of the wave is affected by three factors: the duration of the wind, the strength of the wind, and the fetch, which is the distance that a wave travels. So, yeah. Let's just get some wave terminology, so that means words, definitions going. Okay, crest. As you can see by this diagram, the crest is the top of the wave, and the trough is the bottom of the wave, so the low area. And the wavelength is the distance between two crests or two troughs. And the wave height is the distance between the crest and the trough. So in physics, half of it is called the Jesus Christ, I don't even remember what it's called. Amplitude. Here in geography, wave height is just twice the amplitude. Wave frequency, which is the number of waves per minute. Velocity is the speed that a wave is traveling, and that speed is influenced by the wind, the fetch, and the depth of the water. Swash is the movement of water and load up the beach. So when the wave breaks on the coast, on the beach, it brings up the water and load, so like little pebbles or whatever. Swash, it goes on the beach. Backwash, as you can see, back should be the telltale sign. It's exactly the opposite of the swash. It's when the water and the load goes back down the beach, so back towards the ocean or sea or whatever. So, yeah. Wave refraction. Coastlines are very rarely perfectly straight. They normally have a series of bays and headlands. As you already know, as waves reach shallower water, the bottom of the waves experience greater friction with sea bed. This greater friction causes the waves to slow down. If you have a series of bays and headlands, waves will start to slow down around the headland where the water is shallower, but continue to travel more quickly into the bay area where the water is deeper. Because the section of the wave centered on the headland is traveling slowly and the sections either side are traveling more quickly, the wave begins to bend around the headland. This concentrates the wave energy on the headland and disperses the energy across the bay. So, there are different kinds of waves. Firstly, let's look at a destructive wave. Destructive waves have a fairly weak swash, so they are not very strong in bringing stuff up and water and load up the coast, because the wave breaks almost vertically. However, it does have a much stronger backwash. Because the backwash is stronger than the swash, destructive waves erode and transport materials away from beaches. Think of it like this. Destructive, they're bad, they don't want to help you. Instead, they're trying to steal what you got. They're being destructive. They don't want to help you. Instead, they're taking it away. So it's the water and load that it brings up is one thing, but the water and load that it takes back is more. So it's effectively making the beach smaller and eventually will erode it completely. Now the opposite is the constructive wave. They have a strong swash and a much weaker backwash. So because the swash is stronger than the backwash, they tend to deposit material and build beaches up. So they're trying to be constructive, they're trying to help. So they give more than they take. So coastal erosion. Coasts being at the boundary of the land and the sea are extremely vulnerable to erosion. They are attacked by the immense power of the sea and the weather. Later you will look at one of the fastest eroding coastlines in the world. Actually, you won't. I'm not using that case study, I'm using a different one. But anyways, the main ways that the sea erodes the coast are hydraulic pressure. This is when the sea water and air get trapped in cracks of rock. The increasing pressure of the water and air causes the rocks to crack. So that's fairly simple. You know, when the wave breaks, air and water is compressed into these cracks, and obviously over time it'll weaken the cracks and eventually cause the whole rock to crack. Corrosion or abrasion. Rocks that have been thrown into the cliffs by waves and breaking off bits at the cliff. Think of it like a bit like sandpaper. Sandpapering the wall. You're kind of rubbing on it, so it's kind of breaking apart. That's what is happening, except the rocks are being thrown at it, not sandpaper. But basically, they're wearing down the cliffs because the rocks are being thrown at them, and this is called corrosion or abrasion. Next, you've got corrosion, which, as you should know from science, what it is, or known as solution. This is when the slight acidity of the seawater, so the chemicals in the water that make it slightly acidic, cause bits of the cliffs to dissolve. So it's a chemical reaction, it's dissolving. That's called corrosion or solution. Next, you've got attrition. This is when rocks, sand, and stones are being thrown into each other by the sea current and waves, so effectively making themselves smaller and smaller, and less angular and more smooth and stuff. And then eventually sand is formed, basically. So that's attrition, when they go against each other. And now, wave pounding. This is the immense power of waves crashing into cliffs that causes them to weaken. Ignore that last one. It's not our syllabus. Okay, bays and headlands. Bays and headlands are formed in very similar ways to rapids, which we'll look at in the rivers topic. They are formed when you get alternate layers of hard and soft rock. The sea is able to erode the soft rock a lot quicker than the hard rock, so making a bay. The harder rock forms a headland. So think of it, wait, where's my mouse? So kind of look at my mouse now. Look at the picture, it's here. So think of it, there was a large, this was all, ignore the sea part, think this was all the earth, right? Well, land. So then the half here where there's the water, this was soft rock, right? Now here where you can still see it's not totally eroded, this was hard rock. But it was one huge thingy here. Well, the soft rock erodes obviously a lot easier than the hard one. So the soft rock would erode, whereas the hard one wouldn't, or if it would, nowhere near as much and as quick. So then it formed a bay. So that's fairly easy to understand. And then the hard rock, since it sticks out, we call it a headland. So what's a bay? Well, a bay is an indented area of land normally found between two headlands. Bays are usually more sheltered, so there is less erosive power, meaning you often find beaches in bays. What's a headland? Well, a headland is a piece of land that sticks out into the sea. Waves refract around the headland, so they experience a lot of erosion. So they will experience like landforms, which we'll look at in a second. Wave-cut notch and wave-cut platform. Wave-cut platforms are made in similar ways to waterfalls and gorges, which we'll look at in the rivers topic. At high tide, the power of the sea attacks and erodes the bottom of the cliff. Wait, let me reread that because I didn't understand that. At high tide, the power of the sea attacks and erodes the bottom of the cliff. Okay, so you know when that tide, which we have every day, is high, the waves and stuff, they attack and erode the bottom of the cliff. Over time, this erosion creates a wave-cut notch. Here, look at my mouse on the diagram here. This is created, a wave-cut notch. And as the wave-cut notch gets bigger, the weight of the rock above the notch gets greater. Eventually, the cliff can't support its own weight, and it collapses. The process starts again, with the erosion of the sea making a new wave-cut notch. As the process continues, the cliff starts to move backwards, so it retreats. Because the cliff is moving backwards, a wave-cut platform, which is an expanse of bare rock, is created. Wave-cut platforms are only visible at low tide. So basically, what the wave-cut notch is, that's the wave-cut notch, and then when the rock falls over time, and especially with all the other erosion and stuff, it kind of forms a platform on the bottom. So it kind of flattens. First, obviously, you've got the big rocks here, but then over time they erode and they flatten out and they form another platform here, right? But you can only see it during low tide. So, caves, arches, stacks, and stumps. Caves, arches, stacks, and stumps are usually found on headlands, where wave refraction is causing erosion on three whole sides. The waves always look for weaknesses in the headland, so cracks and joints. If they find a crack or a joint, they will start attacking it. Hydraulic pressure will be the main type of erosion. Over time, the crack may turn into a cave. Slowly, the cave will get bigger and cut all the way through the headland, making an arch. And as the arch gets bigger, the weight of the arch roof gets too great and it collapses, leaving a stack. The stack is then eroded by the sea and weathered from the air, leaving a stump. So now transportation. Firstly, let's look at longshore drift. This is the process of waves moving material along a coastline. So, yeah. Swash is the waves breaking and traveling up the beach carrying load. Waves will break and the swash will travel in the direction of the wind. Backwash. The waves returning to the sea with load. Waves will take the shortest possible route back to the sea because of gravity. So, let's think about longshore drift. Well, it only happens when the waves hit the beach at an angle. It is the process of the swash transporting material up the beach at an angle and the backwash returning directly under the force of gravity that causes material to be transported along the beach. So look at my mouse down here. See, you've got this orange thing. Imagine this is the beach and this is the sea. Well, what happens? For instance, the swash goes here, the waves, so my mouse is now going to go the direction of the wave. It goes here, so then it brings up load and water here, but then when it goes back, it goes, what? Where's my mouse gone? When it goes back, it goes this way. See what I'm saying? So it comes in here, but it leaves here. Then it'll come in here and leave here. And this is longshore drift, so it kind of moves the material along a coastline since it's always going shoo, shoo, shoo. So, prevailing, or otherwise known as the dominant wind, this is the direction that the wind normally hits a coastline. A groin, well, they're wooden or concrete fences / walls that are placed out into the sea to stop longshore drift from happening. So they're kind of barriers, so that even if the sea tries to push the stuff there, it's just not possible. So a groin is a way to stop longshore drift. Sea currents. Currents are the movement of water caused by differences in temperature, changes in wind, or tides. Currents can be extremely strong and can transport... Sorry, I just got a text. Currents can be extremely strong and can transport large amounts of material. Saltation. The wind can also transport sand and even small stones across a beach. The process of wind bouncing sand and small stones along a beach is known as saltation. So, tides. Tides are the twice daily movement of the sea in and out. Tides are constant and are caused by the gravitational pull of the moon. Some tidal ranges can only be a few meters, others can be several kilometers. Tidal range is the difference or area between high tide and low tide. Spring tides, this is when the moon and the sun are in complete alignment, so you will get particularly high and low tides. So, depositional landforms. Spits, bars, and tombolos are all made by a combination of longshore drift and deposition. They are collectively known as depositional landforms. So, a spit. What's a spit? Well, a spit is a long, thin stretch of sand, connected to the mainland, but stretching out into sea. Spits are formed in areas of calmer water, where the sea has less energy. They are normally found near the mouth of rivers, where the coastline changes direction, so they create some kind of protection. So the longshore drift happens in the direction of the prevailing wind, and then when the direction of the coast changes, longshore drift doesn't stop, but continues out into the sea. If the sea has less energy, because it's protected, material is deposited instead of transported. If deposition is greater than erosion, then over time a spit will build up. The end of the spit is usually hooked because of occasional winds and storms that blow in the opposite direction of the prevailing wind. A salt marsh. What is that? Well, it's a low-energy, intertidal ecosystem that develops behind a spit. The salt marsh will have some salt-resistant vegetation. Tombolo. This is a spit that joins the mainland with an island. What's the mainland? Well, it's the mainland mass of an area. Strangely, the UK is described as an island within Europe and the world. However, when you just talk about the UK, you would describe the main island as the mainland. What's an island? Well, it's a small body of land found in oceans and seas. What's a bar? Well, it's a spit that connects two headlands, or runs across the face of a small cove, or bay. What's a lagoon? Well, the saltwater lake that develops behind a bar, which is, like I just said, the spit that connects two headlands. Over time, the lagoon will become smaller as deposition takes place. So let's just quickly go over again. How is a spit formed? Well, you've got direction of longshore drift. So the swash comes in here, but then here's the backwash. So it keeps moving the stuff along the coast, right? Because of the prevailing wind. And then it keeps going like that, right? And now here, look at it. The coast suddenly doesn't keep going like this. It changes here, right? It changes the shape. So, but the direction of the prevailing wind does not change. So the longshore drift keeps going on, and keeps going on in the same direction rather than follow the coast. But there are some kind of movements there because of wind or waves, but only short-term change. It's generally keeping up the trend of just jutting out. And then that's how the spit is formed. But behind a spit, so inside it, you will always find a salt marsh. Okay, the formation of a bar. What happens is you've got, again, direction of longshore drift because of the prevailing wind direction. And then a bar, so here you've got your two headlands and a lagoon. Well, the lagoon is not a lagoon yet, but it's a bay. And then the longshore drift keeps happening like this. And then a bar is formed as a spit grows across a bay and joins up two headlands. So it effectively blocks these two headlands. And that, my friends, creates a lagoon, which, like I said before, is an area of water dammed by the bar. And it will gradually be filled up by deposition. So, lastly, let's look at the formation of a tombolo. Again, because of the prevailing wind direction, you've got the longshore drift happening here. And then basically, even though the headland shape changes, the longshore drift direction doesn't, so a spit is formed, and the spit grows out from the mainland and joins an island. And when that happens, you call it a tombolo. So that's the mainland, and that's just an island, so that's another good example.